Okay, so when we look at what we call linear equations in two variables, such as x plus y equals 5, solutions to equations like this have to specify an x and a y value at the same time that make the equation true. So for example, a solution to this equation would be the pair x equals 0, y equals 5, because 0 plus 5 is 5. And typically we represent x and y values, not like this, but with ordered pairs, so we'd represent it as 0, 5, which of course then we could graph on a plane as 0, the x is 0, the x-axis is here, the y is up here, 0, 5 would be right there. So solutions are ordered pairs that make the equation true, and you can see there are many more of them. For example, 1, 4, negative 10, 15, and this list goes on infinitely. So the interesting thing about this list is it goes on infinitely, and if you plot all of the ordered pairs that make this equation true, they form a straight line. So if the equation has two variables or one variable and each variable is to the first power, makes it linear, and so if you were to graph all the ordered pairs, they form a straight line. So let's finish graphing this line. Since we know it's a straight line, we need two ordered pairs at least, because if you know 2 points on a graph, a graph of a line, then you can draw the line. But we're going to go ahead and do 3 points to check ourselves. For example, if our first 2 points look like this and then our third one is up here, then we've got a problem, because those 3 lines, when you connect them, don't form a straight line. Or sorry, those 3 points don't form a straight line. So that third point serves as a check for the other 2. Well, we already said the ordered pair 0, 5 makes this true. And now what I want to do is choose, we need 2 more, so I'll choose a value for y and then figure out what x is. And we'll choose another value for x and figure out what y is. Okay? So let's first choose a value for y. So let's choose 0 for y. If y is 0, substitute that in, we get x plus 0 equals 5, so x equals 5. And we get another ordered pair where x is 5 and y is 0. If we choose something like negative 6 for y, or sorry, negative 6 for x, then we get negative 6 plus y equals 5. Add 6 to both sides and we can see that y is 11. So we get another ordered pair. Now this ordered pair doesn't fit in this plane because they only go 5 left, right, up, and down. So let's choose a different one. Let's choose an x of negative 2. We get negative 2 plus y equals 5. Adding 2 to both sides, we get y equals 7. And we get another ordered pair. So let's plot all 3 ordered pairs and see if they fit on the same line. Negative 2, 7 might be like up here. That seems like a reasonable ordered pair. And now we just connect them with a straight line because there are an infinite number of ordered pairs. So we need to make sure to indicate that line goes on forever. And now every ordered pair on this line makes this equation true, and any ordered pair not on the line makes it false. Here's another equation we want to graph. Let's set up our table. Again, we can choose any value for x or y and solve for the other. I'm going to choose values for x because I see that if I choose values for x, that might cancel out this fraction and make our life a lot easier. So I might choose 0 for x, that's the obvious choice. Figure out y. If I choose 4 for x, that's a good choice because 4 will cancel with this denominator of 4. And I could choose negative 4. I could choose any multiple of 4. So for example, I could choose 8 and figure out what y is. So we get 2 plus 3/4 times 0 equals y, so y equals 2. 2 plus 3/4 times 4 equals y. Well, 4 and 4 cancel. 2 plus 3 is 5. So we get 5 up here, 2 here. 2 plus 3/4 times 8 equals y. The 8 and the 4 cancel, leaving 2 and 1. So 2 plus 3 times 2 is 2 plus 6, which is 8. Let's graph those points. Those points seem to form a straight line. Connect them. Put the arrows on the end, and now we have our infinite ordered pairs.